All right. Hello, everyone. I hope you can hear me well. And my name is Sergey Maschenko. I am from Sharcnet, based at McMaster University. And at McMaster University, Sharcnet is hosted by the Department of Research and High Performance Computing, RHPCS. Sharcnet is the member of the national organization called Digital Research Alliance of Canada, or the Alliance for short. Today's topic is Advanced Research Computing Update, New Resources and Training. So the plan is to spend the next 40 minutes or so going through the slides, and then there will be time for questions at the end. So what kind of resources the Alliance provides to researchers? You can put them into three large categories. One is the HPC clusters. We have 5 national systems, which are clusters. Each cluster consists of thousands of individual computers. We call them nodes. And each node these days have lots of resources, lots of CPU cores. After recent upgrade we did this summer, I'll be talking more about that later. Now each node has 192 CPU cores. I'll give you more details later. And all these nodes are connected through super fast interconnect, networking. And what kind of stuff can be run on these clusters? So, for example, you can run small computations, but many of them, like thousands of them, or maybe millions of them. On the other opposite extreme, you can run one large, massively parallel application, maybe using thousands of CPU cores. And of course, most of users just do something in between. The other second type of hardware resource Alliance provides is clouds infrastructure, which allows researchers to spawn or launch virtual machines. I'll discuss a bit more later how to do that and what kind of use of VMs might be. And there's some limited amount of CPU and GPU resources available on clouds. But if you need to use lots of CPU cores and GPUs, you definitely should instead use HPC clusters. And of course, there is a need for storage for both clusters and clouds, so we also provide lots of storage for our researchers. When do you need to consider to apply to get an Alliance account? Let me jump first to the most important point at the bottom. So the accounts are free and the resources we provide to Canadian researchers are free. But then let's go through these points, the other points listed above. I think I can summarize them. When you, as a researcher, you have access to your own resources, your laptop, your maybe workstation in your lab, maybe a small cluster in your lab. So when those resources are not enough to achieve what you need in terms of computations, then basically you need to apply for Alliance account. More specifically, your computations run forever, so you need more CPU cores, or maybe you need new modern GPUs. Maybe you need lots of memory, that you don't have enough of RAM in your computer, or you need lots of storage space. And there might be some more technical reasons to apply for Alliance account. For example, you need someone to host a research portal for you or to help you to do that, to host a database, to provide the infrastructure to launch virtual machines in the cloud. So all of these and more is what Alliance provided to our researchers. Here's the map of Canada and also map of the Alliance, which is a national organization. It consists of 5, used to be 4, now it's 5 regional partners. And some of these regions host a national host site. So there are 5 major national sites, 5 clusters, and they're also marked on this map. So now we have BC DRI group, Prairies DRI group, we have Compute Ontario, and Sharcnet is part of it. The other 2 major consortia parts of Compute Ontario are Scinet, based at University of Toronto, and CAC, basically Queens and Ottawa. And then we also have Calcul, Quebec, and eastern provinces are covered by AceNet. Zooming in on Sharcnet specifically, you can see Sharcnet spans a big chunk of Ontario. Sharcnet stands for Shared Hierarchical Academic Research Computing Network. We have a long history. We've been around for more than 20 years, since 2001 or so. Currently, we have 19 member institutions, universities, and colleges in Ontario, and McMaster was one of the founding members of Sharcnet. Important point for researchers, it doesn't matter whether the institution is a member institution of Sharcnet or not. You have the same, once you have Alliance account, you have the same access to any national cluster, any national resources. I keep talking about 5 national sites and clusters. These are the names, the current names. So recently we went through a major upgrades. As a result, 4 out of 5 national systems were rebuilt from scratch using much newer hardware and much larger amounts of resources, such as CPU cores and memory. Only one system, Narwhal, listed at the bottom, hasn't gone through upgrade yet. The rest of 4 systems, they were upgraded, and as a result, they also got new names. So the new names are FIR, NIBI, which is operated by Sharcnet, Trillium, and Rockwell. To access our clusters through a more traditional way, using a text terminal SSH command. So what you need to know the name of the cluster. So you type your command SSH cluster name NIBI, for example, .alliancecan.ca. This is the full address of the cluster when using SSH way to access it. All of our national systems now can also be accessed for more, more interactive way using your browser. Some systems allow you to use just one, like Jupyter Hub, but on NIBI and also on Trillium clusters, we installed a new setup. It's called On Demand. It's actually more versatile and powerful than Jupyter Hub. And you can still run Jupyter Hub under On Demand if you need to. And the address you need to type in your browser is ondemand.sharcnet.ca. That's how you access NIBI cluster through on-demand interface. And to finish off, the cloud services provided across Canada, there are 4 of them. They have names Arbutus, Cedar, NIBI, and Beluga. And the address, full URL, you need to put in your browser. You have to add .cloud.alliancecan.ca. And I strongly suspect the Cedar and Beluga will be renamed at some point, because these are the old cluster names. Cedar became FIR, Beluga became Rockwell. So I suspect at some point in the future, the cloud names will match, and they will change to match the cluster names. Just a slide just to give you a glimpse on what kind of breadth and variety of research supported at McMaster by Alliance resources. These are just 5 researchers and research teams I picked. These are some of the bigger users based at McMaster University using our resources last year. So you can see there are a variety of disciplines covered here, from medicine to astrophysics to chemical engineering to mathematics and statistics to earth, environment, and society. And of course, there are many, many more other fields not listed here. So let's get down to more specific to the details. How much resources you can get access to once you get an account. I already mentioned we went through a major upgrade early this summer, this year. And among other things, we significantly increased number of CPU cores available and also memory, RAM. So in terms of CPU cores, now across Canada, across 5 national systems, the total is 750,000. So it's a very significant improvements to compared to what we had before, basically by a factor of 4. In terms of GPUs, we actually went down in terms of number of GPUs, but these are all pretty much universally modern H100 NVIDIA GPUs, with the one exception, Narwhal is still using the previous generation A100 GPU. These are much more powerful devices, and also most of these GPUs are split into virtual GPUs, so-called MIGs. So in fact, researchers will see many thousands of logical or virtual GPUs available to them of varying sizes. So its setup is also, it's an improvement, significant improvement compared to what we had last year. In terms of storage, the total storage across 5 national sites is approaching 20 petabytes. And just as a historical reference, the 4 systems which were decommissioned earlier this year were Cedar, Graham, which was operated by Sharcnet, Niagara, And Beluga, so Beluga is the only one which you can still log into, but only to log in note, compute notes were decommissioned. And here's a slide describing how easy it is to get an account. It's 4-step, but essentially 3-step. Step 1 is basically to decide whether you need to apply for account or not. Hopefully at this point, you or realize you need one if you don't have one yet. So the rest is just 3 easy steps. And basically, if you're faculty, you have slightly different procedure. But both for students and faculty, what you do, you go to this website, ccdb.alliancecat.ca, you fill out a form, and you submit the form. The slight difference is if you're a student, you need in that form you're filling out, you have to provide the basically ID of your supervisor. You have to ask your supervisor what's their ID number is, and once you have it, you can put in your application. So again, if you're faculty, your application may take a few days to be approved. Someone has to actually verify you are a faculty at that particular institution, typically a few days. If it takes longer, please contact us. I'll show you later by submitting a ticket. If you're a student or postdoc or collaborator, it's almost instantaneous. Your supervisor gets email almost right away. There is a link in that email. Once the supervisor clicks on that link, you're approved and you're good to go. So step 4, basically, you get an account, you can instantly start using our national systems. Once you have an account, there are 3. Okay, so we have lots of resources, but we also have lots of Canadian researchers using these resources. So access is shared, it's competitive. So to handle it, well, we provide 3 different levels of access to our resources. So the default level is already powerful enough for most of our researchers. So most of our researchers never bother to go to the next levels. In particular, in terms of compute, you can have access any amount of CPU cores or GPUs in principle, but you have a lower priority compared to some of the high level of access, like a rack, for example. But again, for most of researchers, that's just good enough. As long as you don't ask for too many CPU cores and too many GPUs, your jobs don't wait in queue too long, so your computation proceed at a good pace. In terms of storage, the default amount of storage is 50 gigabyte on a home file system, which is quite limited file system. Most of stuff you want to do on our clusters is a project. And by the way, these file systems are per national system. Each of the 5 national systems gives you 1 terabyte of project for the whole research group, by the way. 50 gigabyte home for each user, 20 terabyte of scratch space per user. And also we have a tape-based archival facility. We call it Nearline. For those who are planning to use cloud infrastructure, these are the default amounts. You can use up to 80 virtual CPUs years in a year. You can also have up to 25 persistent CPUs, CPU cores. So you can run something like a web server throughout the year uninterrupted if you need to. And also 10 terabyte volume and snapshot storage. Okay, so if this amount of resources is not enough, for example, you need more storage than you currently have access to. The next level of access, so sort of elevated level, is RAS, Rapid Access Service. For example, you need more storage. All we need to do is send an email to our ticketing system. So most of the help provided through ticketing system, you just send an email to support@tech.alliancecan.ca and ask for up to 40 terabyte of project space across the country, across the 4 national sites. Trillium is a special cluster, is not participating in this calculation. But across 4 other national sites, up to 40 terabyte, basically no questions asked. If you need it, we're going to grant it to you. And you can do it at any time. In terms of compute, we may be able to accommodate, sort of boost your priority for if you have crunch time, the conference is coming, you need to produce results sooner. Submit a ticket. We will try to accommodate you, but you have to understand sometimes, like right before Christmas is a bad time. Everyone has crunch time, so we may not be able to accommodate last moment requests like that. But for people who chronically, for the research groups, chronically having not enough of resources, you're waiting forever in queue, you're not getting the throughput you need, the highest level of access to our systems is Resource Allocation Competition, or RAC. Again, to emphasize, most of our users don't need that. These are for minority of research groups who are large users, who really need lots of storage, lots of compute. So those groups should definitely apply for the RAC, which is it's an annual process, and it happens every fall. And current RAC is running right now, so you definitely need to consider whether you need one or not. And the supervisor, the head of the research group, have to decide if they need it. Deadline is approaching, is early November, so you should be applying soon. And you, to be able to apply for RAC, you really need to request lots of resources above 200 CPU cores or 25 reference GPU units. These are special GPU units we came up with, or more than 40 terabyte of project space, or more than 100 terabyte of nearline space. And these are the limits for minimum limits for the cloud RAC applications. So let's say a few more words about RAC process. Again, it's an annual process. It's a peer-reviewed. The supervisor needs to fill out a few pages justifying the science and also justifying the technical aspects and the amount of resources requested. The deadline for current process, which is already running, is November 4, so it's a bit more than 2 weeks, so you definitely want to act sooner rather than later. And especially if you're doing it for the first time, do not delay it until last day or last week even. If you're doing it for the first time, you really want to request a consultation with one of our staff. Just submit a ticket to the ticketing system, and one of our staff will be happy to assist you to go through all those technical issues, how to fill out the application, how to make a successful application. And again, don't do it last moment. We won't be able to help if you request help on November 4, for example. We did some sessions, information sessions recently, both English and French language. Recordings and slides are available if you follow this link. By the way, I'm recording this presentation and it will be shared. I believe I just put in our YouTube channel. So whatever information you see here, you'll be able to access after this meeting is over. All right, so let's talk a bit more about the new way to access our systems, the interactive way or graphical way. It's ondemand.sharcnet.ca. It's based on your browser only. You don't need to install anything. And you just enter this URL into your browser, and this is what you see on your first page. And also, we use unified authentication across all of our systems. Whether you do SSH to our clusters, whether you go to CCDB websites, whether you use on-demand or Jupyter Hub or anything else, using cloud, for example, it's the same credentials, the same login name, the same password. And also, now we are enforcing MFA, second factor authentication. For most researchers, this is basically you installing a Duo app on your phone. And every time you log into a cluster or using on-demand or going to CCDB website, you have to enter your password, and then you also have to approve this request on your phone. This is done for security reasons. So what's happening once you access on-demand? Basically, when you are on your browser accessing on-demand, you're accessing a login node of an EB cluster. So what you can do there, you can do a few things even without requesting a compute node. You can do things you normally do on the login nodes of the cluster. You can do some file management, for example. You can copy files back and forth. So for that, you don't need to request a compute node and wait for it. And this is one of the advantages versus Jupyter Hub, where you always have to request a compute node before you do anything. Another thing, you can launch a compute desktop on a compute node. It's a fully fledged Linux desktop where you can do whatever you want. You can open text terminal, you can run GUI applications, you can run a browser and do things through your browser. You can run MATLAB and any other things where there is need for GUI access and interactivity. Like the compute desktop is actually running on a compute node. So when you request a compute desktop, you may need to wait a bit because this job needs to be allocated and run on one of the compute nodes. If you ask for lots of resources, lots of CPU cores, lots of memory, GPUs, you may end up waiting longer. If it's small resources, it's going to be almost instantaneous. So for you just to be aware. Most of our users are still using it's very powerful way to access our system using text terminals. So whether you're using Windows, Linux, or Mac, you just open your text terminal, you type SSH command, cluster name, let's say nibi.alliancescan.ca, uh, and the what things you do on a cluster, you end up on the login node, and most of the resources are consumed by submitting a job to our scheduler, basically. And this job script consists of a few lines. Each line requests a certain amount of resources. And in this particular example, we are requesting 64 CPU cores, 1 GB of RAM per core, and also runtime. We have to specify what's the runtime. We're asking for a short job for only 30 minutes, and we have to provide account name. There might be some other switches you need to use. And then what follows, these are one or more commands you'll be executing once the job is actually running. And then in your terminal, you submit the jobs by saying sbatch and then the name of your job script. Once it's submitted, you can check its status by running sq command and -u your username, or there is a shortcut, 2 letters, SQ, to replace the whole sequence shown here. And then it will show you whether your job is waiting, pending. In this case, this is PD, waiting. When it's running, we're going to change to R. And again, a reminder, this is a non-interactive type of environment. So you submit a non-interactive job and wait until results are finished, and then you can, process your results. Let's say a few words about accessing the cloud. So clouds are provided as an infrastructure as a service. So that means users are responsible for running virtual machines. So whatever happens inside your virtual machines, whatever you do inside virtual machines, it's your responsibility. I think I already mentioned VMs are Linux based, so you need to know some Linux to be able to do that, to run VMs. We can help you, provide you with some tutorials on Linux, etc., but it's your responsibility. And typical uses of cloud, web services, for example, you want to build a research portal, so anyway, anyone in the world can do something on this portal, set up databases. You may be able to run some computer-intensive applications up to the limit. It's not large scale, and some other ways you can use VMs. Before you proceed, you have to visit this wiki page, and one of the things it tells you to do, you have to create a project. So only PI, the faculty, the supervisor can create a cloud project, one per cloud. And once it's created, then you can start accessing the cloud, the project through the web browser. You can choose what kind of VM you want to run. And the interface looks something like this. Once the project is created, you go into one of the cloud. You enter the URL into your browser, and then you choose the configuration of your VM. You operate your VM basically using the web interface. A few important points here. We do not provide Windows images. So if you have software which is Windows only, you cannot run it unfortunately, in our VM on our clouds. All VMs are Linux based. And here I repeat the limits for the default usage of our clouds. One slide is about copying data. In particular, if you need to copy lots of data. For smaller amounts of file copying, you can use either terminal access. You just type commands such as scp or rsync, whatever used to the Linux commands. Also on demand, if you run it on demand, there is some interface. You can initiate file copying from there. But this is for relatively small amount of copying. If you need to copy relatively large amounts of data, let's say more than 50 GB or so, the best or sometimes the only way to do it is through the web-based tool called Globus. So check this wiki page for more details. You typically need to install a small program on your computer. You have to register your computer as a Globus node. And once you do that, you can open two tabs in your browser, and you can initiate copying either between two different clusters or between your computer and a cluster. And good point, a good advantage of this approach is you use this interface to initiate the copying, and then you can close your browser, you can shut down your computer. It will continue in the background somewhere. And once it's successfully accomplished, you're gonna get a notification email. And the final sort of section of my presentation, let's talk about getting help and training. We have one massive resource. All the technical documentation goes to this national Wikipedia, effectively, docs.alliancecat.ca. Users can actually request edits if there are some problems, issues with the pages you find. This needs to be approved by staff, but the idea is the same as in Wikipedia. There are hundreds, probably thousands of wiki pages on this in this resource on all kind of topics, different research software, talking about schedulers, storage, policies, etc., etc. This is all located on this website. We still maintain a Sharcnet only portal, sharcnet.ca, and these days this is primarily for training purposes. Our events calendar, announcing our training events, things like that. More about that later. So again, if you need help, the main primary source of getting help is by submitting a ticket, by sending an email to support@techalliancecan.ca. We also have weekly, every Tuesday at 2 p.m., we have live Q&A sessions for new users primarily, but you can show up if you want, if you have some questions. You need to register for these using our events calendar. You're welcome to also contact us directly. In Sharcnet, we have around 25 personnel spread across multiple sites, and roughly half of these people are user support who directly do user support. Other people are sysadmins and administrative personnel. So you're welcome to contact us directly through email or phone. Check out the directory on this website. And at McMaster University, there are 4 of us, 4 people. We are all located in ABB building. We all work for RHPCS department. And we have sysadmin Mark Hahn, who is in this meeting present. Myself, I'm an HPC analyst. We have Servilia software developer and also Wegwan software developer, who is also our AI and machine learning expert. Here's the list of all the training we do. These days, it's pretty much all online training. I already mentioned events calendar. You can subscribe to this calendar. We do Q&A sessions for new users. I already mentioned that. We also do bi-weekly genuine interest seminars at noon on alternative Wednesdays. They're also listed in our events calendar. These webinars are about some recent trends, new topics, new software, tools, new developments in the lines, anything of interest to our users. These are normally delivered by Sharcnet staff every second Wednesday. We record these webinars and I edit them and post to our YouTube channel listed here. So please consider subscribing to the channel to get automatic notification. The URL alias is youtube.sharcnet.ca. We also run live online training every fall and winter between October and April. So we already started running our live courses. Every Tuesday and Friday at 1 p.m. They're again listed on our events calendar. You have to register specific courses you want to attend. The series is called Introduction to ARC. And the largest training event of the year is called Computer and Terror Summer School. Sharcnet is participating in this event. I'll say a few words later. The recent exciting development, Sharcnet started creating self-paced online courses for people who have time conflicts, cannot wait, or cannot attend any of our live training. Now we have around 10 self-paced courses. You can register any time of the year. You can attend anytime you want. Take it at your pace. All of these courses have completion criteria at the end, either quiz or assignments, and if you successfully do those assignments, you can get a certificate of completion. Most of these training courses are accessible through training.sharcnet.ca. You can use your CCTB Alliance credentials to log in, or in this case, yeah, this is the only way. But we also, things like summer school, they're hosted on another site, which looks very similar. It's using the same LMS. It's called Moodle. The other side is training.computeontario.ca, and this is used for summer school. So summer schools we've been running for a number of years, and they're getting bigger and bigger and bigger. Last year's school was 3 weeks long, 2 parallel streams, 6 hours of training in each stream. We had more than 40 courses, and we had more than 1,000 people attending these courses. I think around 2,000 people registered. So these are very large training events. Stay tuned. They will be advertised typically in May, and they run every June. And I think this is this is the last slide. This is not the exhaustive list, but this is some of the training courses we do either as live courses or as self-paced courses. So as you can see, we cover a large variety of topics. Supercomputing, shell, machine learning, SQL, C++, Fortran, etc., etc. For the full list, please check the training.sharcnet.ca website. So I reached the end of this presentation. I'm gonna stop the recording.